Imagine squeezing the entire mass of our sun into something no bigger than a city. That's a neutron star, nature's way of making the heaviest, tiniest object possible without it turning into a black hole. Welcome to the Cosmos in 5. Today we are talking about the neutron star, the densest object you can imagine. So what exactly is a neutron star? A neutron star is the super dense leftover core of a massive star that blew up in a supernova. It's tiny, only about 10 to 20 kilometers wide, like the distance across the small town, but it holds the mass of 1 or 2 suns. A single teaspoon of its material would weigh billions of tons on Earth. That's denser than anything we can make in a lab. The whole star is basically one giant ball of neutrons packed so tight that atoms have completely broken down. How does this happen? It starts with a big star, at least 8 times heavier than our Sun. After it burns through all its fuel, the core can no longer fight gravity. In a split second, it collapses, then explodes outward in a supernova. The outer layers fly off into the space, but the core gets crushed so hard that protons and electrons smash together to form neutrons. What's left in a neutron star? Spinning at crazy speed with a magnetic field trillions of times stronger than Earth's. Just how dense is it? The density is mind-blowing. Gravity on the surface is billions of times stronger than on Earth. A marshmallow dropped from 1 meter would hit like an atomic bomb. Mountains on a neutron star are only a few millimeters high because the pull is so strong. And many neutron stars act like lighthouses. They spin hundreds of times a second and shoot out beams of light and radio waves. We call these spinning ones pulsars. If this crazy density is squashing your brain like a neutron star, smash that like button before it gets too heavy. Share it with your space buddies or the whole video might collapse under its own weight. Can we actually see them? We can't see most neutron stars with normal telescopes because they are so small and faint, but we find them easily with special tools. Pulsars flash like cosmic beacon and we pick them up with radio dishes. Some glow brightly in X-rays when they pull gas from a nearby star. The very first one spotted back in 1967, and today we know thousands scattered across our galaxy. Space telescopes like Chandra keep giving us sharper looks at their wild behavior. Why does that matter? Neutron stars shows us the extreme side of physics. They help scientists test ideas about gravity, nuclear forces, and how heavy elements like gold get spread through space. They also give clues about what happens right before a black hole forms. In a very real way, they connect the life and death of a star to the story of our own planet and everything on it. So here is something to think about as we close. If a teaspoon of neutron star weighs billions of tons, what do you think would happen if we ever brought even a tiny speck to Earth? Drop your wildest guesses in the comments below, and I will see you in the next episode of the Cosmos in 5.